Welcome to Retro Upgrade. This time we'll be taking a look at a fix I did off camera for my car. The handle latch broke inside the door for the interior handle. As you can see here, it actually broke in multiple pieces. I did try to repair this the normal way, glue and remelting the plastic. You can see a few pictures here, but it instantly broke because this handle has a big spring on it and it's super heavy duty, and this is what I ended up with. So this is a really complex shape. It doesn't really have any flat surfaces, and it didn't have everything left as well. But you can see here, I did manage to fix it. Still working after a few months, so that's good. This is the video I used to make a 3D scan of the object. I just fast forwarded here, and as you can see, it's fully functional. I could have done a better job of cutting out the hole for it, but hindsight. But it does work really well. So I was thinking I needed to fix the door handles as well, and this would require really intensive modeling or something else. So this is a perfect candidate for using a 3D scan to fix something. So I have a good reference. This is the handle outside the car. This is the one that's the least broken. It's still broken. The top part mount actually just ripped out the ring inside. It's a captive bushing it has. It's like an insert to keep it from sliding out. It just broke out. As you can see, I've fixed this multiple times. This car was broken by the previous owner. The entire interior of the car is destroyed, so I'm fixing it little by little. So remaking this part is really hard. As you can see, there is no real flat surfaces that you can measure from to another and make a nice replacement one just by modeling. You could do that, but it's really hard. So first of all, to 3D scan something, you can use a 3D scanner, you can use a Kinect, you can use the scanning feature on your iPhone if you have one of the newer ones. I don't, so I opted to use photogrammetry. So this means I use photographs, photographing a lot around the object, and then using a special application to make it a 3D model. So what I'm doing now, I'm using baby powder to highlight the surface details, because shiny stuff and black stuff and transparent stuff don't come out well on photogrammetry. I also tested the nerves. They're still in their infancy. That's a AI-based system that doesn't take as long as photogrammetry does. Photogrammetry is really compute intensive, so if you have a graphics card, it's fine. It takes an hour or so. But if you don't have a good graphics card, you're out of luck. It takes forever. But there are services online for this as well. And you can also use some phone apps as well. They still cost money, so but this works well. So these are the photos I got out, about 100 or so photos. So the more photos you have, the better the model actually comes out, but this came out good enough. Okay, so I'm using Meshroom. This is a special software. It's freeware, so or open source, so you can just download and use it. You drag in your folder with the images. Remove any image you can see with a really harsh shadow. You can see here that the images are quite high quality. I took these with my cell phone, so they are still in normal quality. I think my cell phone camera is 50 megapixels or so. And you don't need to do much here, actually. You just right click on the nodes down there and press calculate. Oh yeah, it was going to prompt you to save, because if any of these steps fail, it will restart from the beginning if you don't save it. So this is a really good idea to do. So, and then the reason I go node by node and press compute instead of pressing start at the top is because it fails a lot if you do that. So it's better to do one step at a time. Here is when you finish to this particular step, you can actually see the point cloud. So you can see what you're working with. If for some reason you see a flat image or some points spread out but nothing else, that means it hasn't latched onto the details and doesn't know how to recreate the 3D object. That means your photos are bad, pretty much. So, okay, so just continue computing everything until the end. When you get the mesh one, you can double click on it, like so. And then on the right side, you can disable the point cloud so you can see the actual mesh, how it looks. So as you can see, there is a lot of extra crap, the actual things I had there to hold it in place, and a little bit of my garden as well. So, but don't worry, we're going to fix that with another free program. The last node is the one we use normally to export. It's the textured node. You just double click it and it appears on the list to the right as well. It's really nice. You can see some small holes, but that doesn't really matter if you're going to recreate the entire thing. If you're using a 3D scanner, you can actually just use the scan and print a new one. So it's high enough resolution that you can do that. Okay, so this is MeshLab. This is also open source and it's free. And go around and use the select grouped objects. I'll show you right here which one that is. It's that one, and you can select different things and just press delete to remove anything that's not there. Don't forget to subscribe. Okay, so let's see. So you remove all the small floating particles, zoom in, zoom out, and spin around just to make sure you get all of them, because the center of the actual object will become the center in between the points. So there's one hiding right there on the right. And this is actually quite easy to do because it takes and selects all the grouped stuff. So zoom in, you have to zoom in a bit, and you can see there's more flying debris. You don't need to be perfect here. And there are a few extra things you can see on the bottom. That was the actual grabbers I used to hold it in place. But doesn't matter because I'm going to 3D model. Like I said, if you had a 3D scanner, you can do it better. Okay, now here comes the important part. Take the ruler, measure a distance inside the program, and then measure the actual distance in real life. You take the real life measurement. In this case, it was 46.35 millimeters, divided by the measurement you get inside the app. And then you get your multiplication factor. So this is used with the transform tool to the right there. And you put it on all three axes, X, Y, and Z. So you actually scale the object to millimeter precision. This is not 100% precise, but it gets you really, really close. Around a half a millimeter in precision, or even better. I actually got it right on my first try, when I actually 3D printed this thing when it's done. So it's not bad at all. I'm just centering it here so I can spin it around freely, but it's not necessary. Now it's time to export. You have a file and export mesh. Just save it as whatever. I usually save it with the images I took. I have to remember where I put them. Desktop. Oh, there we go. And then door handle. So make sure you name it something easy to remember, because you can lose these files. Okay. Now a quick word from our sponsor, PCBWAY. Thanks a lot, PCBWAY, for sponsoring this video. Let's check out their 3D printing this time. Okay, so I upload the file to the viewer. I'm using the handle right now I just designed. You can use the 3D viewer to make sure you can see the entire object. That looks great. Okay, so you have a lot of options here, a lot of materials. So you get different types of printing depending on the material. For example, SLS, FDM, and stuff like that. You also have a lot of options for threading, inserts, and so you also have assemblies if you have a really complex part. They do everything. It obviously adds cost. You also have some sheets to check your dimensions and stuff. So that's great. Visit PCBWAY.com and make your projects come true. Okay, time to go back to the video. Open your CAD software of choice. I'm using Freecad because it has a free license. I can do whatever I want. First step, it's scaled to the right dimensions already, real world dimensions. So you just have to position it so you can model from it. So what I do, I use the axes. First of all, left and right, you can see top and bottom. I sped this up, so you can see now I'm spinning it around and spinning around its own axis. You need to use a plane. I use the XY plane to actually set one of the points so it's exactly flat on it, so I can start drawing from there. So this is a little fiddly. You can see the plane right there. So I'm just clicking around. If you want a full description on how to work in Freecad, there are better sources than me. You can see the plane down there. I have it flat to one of the points, so I can start modeling from there. Mango something, he makes really good Freecad videos. I usually follow his guides when I want to learn a new thing. Okay, so you just use the plane you just made, you make a sketch on it, and then you extrude from there, and you keep doing this until you actually made one of the features of the thing, and then you can make the other feature. I made a total of 3 features and then added them together with a Boolean operator. But this makes it, as you can see here, a lot easier to scale and size everything up. Of course, you can get your calipers out and still measure the things in real world, just in case. But as you saw here, it's missing actually a few pieces because it broke off over time. So what you need to do is just make sure you're building it as close as possible. Obviously, you can see the 3D scan is not great, but it's good enough for this. I use the transparent appearance for making the actual model I'm using for reference transparent, because I'm not actually modeling on top of it. It's a separate body. So I'm just modeling down to the actual flat surface there. And then I'm going to model the base for it. And then I'm going to do the same thing for the other one, for the other protrusion on the other side. Just making a new plane, lowering it down with the offset, and then starting from there. This is the bottom of the actual there, because it has a flat plane there. It's great to start from there. It's not perfect, but it's good enough. I'll jump forward a bit because this took 2 hours, I guess. Reason I'm doing this is because I can't get a hold of the handles in a reasonable price. Okay, so now comes the actual real good use for having a reference. So how do you make the actual sweeping curve of the handle? It's kind of hard. So I use a loft. I use the planes and I rotate them around the reference like I'm doing now. I sped this up so it goes a little faster, but okay, so I need a slice from there. So what I do is I put the plane where I want to slice. I press OK. I make a new sketch on that plane, and then I use this button, and I can actually just see right through it. Because I'm missing the top part of the handle, I have to assume it's there. So I'm going to make it around the circumference and round it out. I am using a B-spline here. It rounds itself out when you close it. There we go. That looks great. Now Let's do a loft. That means it follows all the shapes. This can be done in all 3D applications, so don't worry. This is a little convoluted here because you have to add the first one, then go add the second one, and keep clicking like that and add. Doesn't look like much until you get to the last one. This gives me a really complex shape really easily. And you see something's missing, obviously. I have 3 objects here. So I made both protrusions as well. So I'm going to make them visible now so you can see how accurate I am to the real design. And that's pretty close. You will still see some minor things, and it's not perfect. It's off by a couple of millimeters on the top when I try to fit this to the car. But this is good enough to print and actually test. So, and I made some holes that go all the way through and leaves 4 millimeters of thickness on the bottom where the screw grabs towards the car, just to make it a little bit more rigid. Save the file as an STL. Open it in CURA, sorry, wrong application. Okay, now comes a very important part for 3D printing. I'm not going to go through 3D printing stuff here, but if you want a video on my post-processing or how I decide on how to slice it, I can make one. I'm just going to give a few pointers here. Okay, so the application thinks this is the best orientation. I know for a fact that it isn't, because I'll explain now. So the actual pegs are in line with the layers. So if they get some side forces or left to right, they just rip off because it's the weakest on the layer lines. So this is a bad orientation. But the handle would be really strong in this orientation. So let's try another orientation. I do know which one is the best one, but just for the sake of showing you. So you would think, okay, I have a tall 3D printer, I have a Delta, it's really tall. So I could print it like this easily. Actually, my bed is exactly the size I need for this handle, but I could make it into parts and put a screw, so it's fine. You can see the layer lines in the middle go horizontally on the actual handle. So when you pull on the handle to open the car door or close it, you will break it in the middle. So the layer lines are the weakest point. You can make it thicker using what's it called, more layers inside, and no infill, just make it solid. But that's not necessary. I used 4 layers of outer layers of solid, so it's about 1.5 millimeters thick, and it's good enough. It holds the door. Okay, so I know I want the layer lines going perpendicular to the actual forces. So it sounds a bit hard to explain, but when it's lying down like this, or I think I want it the other way around, upside down, there we go, and angled down. Reason for angled down is because the supports are easier to remove when it's angled, and it prints easier in the air, so I don't need as much as support material. So when it's angled like this, the forces go from side to side on the actual handle, and the actual layer lines go with the pegs direction. So you can see the layers go from left to right and from front to back. The up and down layers. So the only way you can actually break these is twisting the handle. And that's a lot harder to do with a lot of force. Okay, so here as an example, how big this thing is. It's exactly so it fits my 3D printer bed. So yeah, I was a little worried about it not fitting, but it actually fit quite well. And I got a failure during the print. I'll show it in a sec. The failure was that it just stopped printing about 70% the way done. So you can see here, and I reprinted the top only. So if you want a guide on how to finish off a print that fails like this, give me a comment down below and I'll make a dedicated video. I also post-process this. I'm checking the actual size. It looks really close. I noticed I missed a screw hole, but wasn't necessary in the end. I also missed a flange on the top, but that's also not necessary. But it looks really good. And I actually mirrored this part and printed the second one for the other side. The flange is missing on the top. You can see here it's really sturdy. And the post-processing was done with some putty, and I sanded it smooth. What took like 15 minutes. And I'm going to spray paint this the gray that the car has. It's a gray brown-ish. You can see the gap there. It should have a bend or a flange there, but I forgot to add it in the design. Oh well, it's nice. It looks good, considering the door is broken in all places. The cover for the speaker is gone as well, so I'm going to print one for that too. These doors are really heavy. It's a Volvo S60 Mark 1. I have 2 of these. Okay, so now comes the thanks for all the subscribers and all the new viewers. I got to 1,000 subscribers recently. I'm really happy. I'm almost monetized. I just need more view hours. Thanks a lot, guys. See you on the next one. Bye.